Welcome to POWTECH virtual talks on rare earth elements and energy revolution. Sympatec is talking about particle size analysis for quality control of NdFeB mining. Have fun and enjoy the talks.
Your topic today is particle size analysis for quality control of neodymium iron boron milling. Please start with your lecture. You're welcome.
Thank you. So hello everybody. It is my pleasure to meet you all day here. Today's topic is about particle size analysis for quality control of NdFeB milling. As we mentioned, NdFeB is a kind of permanent magnetic materials with excellent magnetic properties. It is widely used in many different fields, such as the car, the aerospace, the electronic products, and many other fields. First of all, I would like to give a brief introduction about our Sympatec. The name of Sympatec comes from system particle technology. From our company's name, it shows that we are focused on particle characterizations. Our vision and mission is better particles with better instruments. Here, better particles refer to customers' products. Sympatec, the inventor and pioneer of dry dispersion, offers a prominent contribution to control, production, and the development of particulate systems of quality and sustainability. We provide continuous innovations that guarantee a better characterizations of products in the original dispersion state, from the laboratory to process. We size your particles. What is the origin of Sympatec? It is powder technology or particle technology. The particle technology is the application of mechanical force for changing the material properties, such as particle size and particle shape and its distributions. Typically, this change is achieved by using different unit operations, such as comminution, agglomeration. These two unit operations change the particle size and shape and these distributions. But some other unit operations, such as the separation, mixing, during these operations, there is no change of size and shape of single particles, but the size distribution was changed. Initially, the unit operation is particle transportation. This process needs to be quantified so that it can be controlled by mechanical force. Therefore, particle size measurement become very important. In the early 1980s, with the initial breakthrough innovation for fast dispersion of dry powder, Sympatec patented dry dispersion system RODOS opened a new dimension for laser diffraction. What you see here is a HELOS RODOS system. HELOS is a laser diffraction spectrometer for analysis particles and particle size distribution from the range of 0.1 to up to 8,750 micron. These systems can measure nearly all products, such as powders, the granulates, the aerosols, sprayers, bubbles, emulsions, and many other different products. And at the same time, provide a reliable results with the highest sensitivity and reproducibility. So here, what you see is a HELOS optical setup. The laser beam is expanded from the optical box to generate a parallel laser beam. The laser beam diameter can be adjusted according to the selected measuring zone, different measuring range. The well dispersed the particles, such as if they're from the dry dispersing system, it will be the free aerosol jet. They passing through the extended measuring zone and of the parallel laser beam without any reagglomeration. The generated diffraction pattern are projected by a Fourier optics to the detector. For our Sympatec, regarding the optical setup, we use parallel laser beam. It is provide a large working distance. Here, there are 3 identical particles at the different positions of the measuring zone with the parallel laser beam. The Fourier lens focuses the diffraction pattern on exactly the same position on the detector. The result we get is these 3 particles has exactly the same size. Only with this parallel laser beam setup, there is no any deviation on the calculated particle size when I'm measuring the free aerosol jet. In contrast to Sympatec's parallel laser beam setup, almost all other laser diffractometers are using a convergent optical setup it is called reverse Fourier setup. The measured sample is behind the Fourier lens. In this convergent optical setup, the focal distance is determined by the distance of the single particles to the detector. From the principle, we know that the focal length is the decisive for the calculated particle size. But in the convergent beam, the focal length will be determined by the single particles with the distance to the detector. The advantages of this setup is a simple and cheap alternative to build a full range systems. Only one optical setup can cover a large particle size range. But the biggest drawback and the source of severe errors of this convergent optical setup is the different focal lengths due to the different distance of the particles to the detector. Here, we have the 3 identical particles. Just because they are in the different positions in the convergent beam, their diffraction pattern obtained on the detector are different. Therefore, they are calculated as 3 different particles with different size. In order to reduce this error, a cuvette is used to force the particles passing through this measuring zone. You can imagine, after dispersion, the particles cloud is forced to pass through this very narrow housing and cuvette in the measuring zone. It definitely will lead to the reagglomeration and deposition. With this convergent optical setup, it cannot measure the free aerosol jet properly. For the particles less than 10 microns, it is nearly impossible to fit the primary particles into the measuring zone. Sympatec, we use the parallel laser beam. The beginning of Sympatec is RODOS. RODOS is a patented dry dispersing system. Initially, this RODOS has been developed for external dispersion for improvement of air classifiers operation. More than 30 years ago, we start to use this RODOS for laser diffraction instrument. We are the first company to open the dry application to laser diffraction with this unrivaled breakthrough innovation. So coming from the particle technologies, we know that in order to get a transfer particle size analysis result, it is very important to disperse the products into the primary particles before the analysis. It is obvious to us if the products generated and used in dry state, it should be measured in the dry state. If the particles generated in a suspension and used in suspension, it should be measured in wet state. But before Sympatec RODOS, all the laser diffraction measurement is wet world. Since in that moment, there is now powerful dry dispersing system. What you see here is our patent dry powder dispersing system, RODOS. What is the principle of this dry powder dispersing system? RODOS can disperse all the fine dry powders, even for the NdFeB real earth magnetic. There's some know-how behind. So here, what you see is the dispersion principle for dry powders. Usually, for disperse the particles, some energies need to be introduced. For dry dispersion, we use the compressed gas. Usually, the compressed air was used as a dispersion energy. The dispersion is achieved with 3 different efforts. After the particles introduced into the dispersion line, the particles subjected to a very strong centrifugal force and the shear force due to the velocity gradings. And the dispersion pressure can be adjusted according to the different product situation. And also in the dispersion line, the particles, there are some correlations. This also can let the particles separate. And in addition, the correlations between the particles and the inner wall of the dispersion line also can cause the particles separate. This combination of these 3 effects achieves very effective dispersion. If we use 3 bars pressure, the velocity of the dispersed aerosol jet coming out from the dispersion line can up to 100 meters per second. With this very fast dispersion, there's no any agglomeration. And for NdFeB measurement, we can see from this a short video. The measurement entire time is less than 30 seconds. You just use a spoon, put the magnetic powder into the chute, and the vibrating device put the material homogeneously into the dispersion line and disperse the particles into a single particles and then do the measurement. It's a very fast measurement. Before this RODOS, in the world, we cannot see the particle size distribution of the NdFeB magnetic powders. Only with this HELOS RODOS, we saw the particle size distributions of the NdFeB powders. As we mentioned before, NdFeB is a very common used magnetic products. In the production for NdFeB, there is a very important steps called the grinding system, grinding steps or milling. Just as what Mr. Duan mentioned, for the NdFeB grinding, usually the jet mill is used. And the particle size distribution is used for a very important criteria for quality control of the NdFeB grinding stage. Why I need to control the particle size distribution in NdFeB productions? As we said, in order to get a very high magnetic properties, the particles cannot be too coarse, also cannot be too fine. If the particles too coarse, the maximum magnetic energy product will be reduced. The intrinsic coercivities will also be drastically reduced. And in addition, the magnet's banded strength also will be reduced. But the particle size also cannot be too fine. This NdFeB material is very special. If the particles are too fine, it will lead to the oxidized and very easy burn. And many of our customers, sometimes their products is become brown and to destroy the production equipment, also our system. So this products, if too fine, it's very easy to lead to fire or burn. And also another situation is if the fine particles are too fine during the sintering, the small particles will be reusing together to create, to form a big crystal. This is also a kind of a big particles. So in order to get a very highest, the most highest magnetic properties, the particle size distribution cannot be too coarse and also cannot be too fine. The particle size distribution should be as narrow as possible. The mean particle size should be as small as possible. Ideally, the particle size, the mean particle size should be controlled at 2.5 to 2.6 micron. Control duct during the production usually is 3 to 5 microns. Since this NdFeB is a dry powder, so it is the ideal application for our HELOS and RODOS dry dispersion system. But for dispersion, this NdFeB, it is very challenging. From this micrograph, you can see because this very strong magnetic adhesion force, the particles stick it together and formed a very strong agglomerate. Only because in the past, there's no way to disperse the magnetic the powder properly. So they cannot see the particle size distribution of the NdFeB powder. Only can use this Fisher subsystem to see the mean size of these magnetic powders. There's not any particle size distribution can be seen. So for us to do the measurement of this NdFeB, the dispersion is the first priority. It's luckily to say, and our HELOS, RODOS, the dry dispersion system, the state-of-art technologies, we can measure the NdFeB particle size distributions properly by using these pictures you saw in the pictures. It's nearly all our customers in the world, especially in China, they use this setup systems. The measuring range, this R2 measurement range is 0.52 to 87.5 micron. We use 4 millimeters dry dispersion system and the vibrating feeder vibrate to send the material homogeneously to the dispersion line. The dispersion procedure also very simple. There is not any need for you to do any samples preparation. You just use spoon, get some samples, put in chute, that's all. The all measurement time is within 30 seconds. Here are 3 different NdFeB powders. For each sample, we measure it separately 3 times. You can see the repeatability of each measurement is very good. The red curve is 3 measurements for this A products. The green curves is 3 measurements. That just repeatability seems as a single curves. And the blue one is another product. From this measurement result, you can see it is a very good reproducibility. This is for dry dispersion. We also did some further study by using white dispersion. This blue color curves is we do the NdFeB measurement by using white dispersion without any sonication. The 3 green curves obtained is by white dispersion, but with 120 seconds sonication. And the mean size D50 you get is around the 20 micron. But by using HELOS RODOS dry dispersion system, you can see actually the mean diameter is only about 4 microns. So application benefits. By using HELOS RODOS dry dispersion systems, customer can get a very high quality of measurement results. This measurement results has very high reproducibility, comparability, and high resolutions. According to samples properties, customers can adjust dispersion pressure to disperse the NdFeB powders to the primary particles completely. And the measurement is very fast. There's no need to clean the systems after each measurement. The very high measurement frequency, we can get a completely particle size distribution result within 30 seconds. We don't need to do any propagation, as we show from the video. Return on investment. With this HELOS RODOS, customer can produce better quality products. Customer can quickly see the out-of-spec milling performance from the test result and make a timely adjustment to the milling process. The customer can measure the full particle size distributions as well as the mean particle size of the NdFeB powders. The customers can best control the milling process to assure best performance of the afterwards pricing and the sintering process. Finally, customer can make sure to get the best final magnetic properties products. This is our Sympatec headquarters location in Germany, Kloster-Zellerfeld. All our instruments are made in Germany. We have professionally trained local agents and our local branches, offices, and branch organizations in all regions of the world in order to serve our customers globally. Until now, we have nearly 98% NdFeB producer in China use our Sympatec patent dry dispersion system HELOS and RODOS. We are very proud. We produced a very powerful tool for our customer to let them can use a very good instrument to control the milling NdFeB process. Welcome to our Sympatec Pulverhaus in the Innovation Center for Particle Measurement. Thank you very much. It is my presentation of today. Thank you.
Thank you very much. Thank you for your presentation.